Good morning, students. If you're watching this video, it's probably Thursday, May 7th. This is our science video for Thursday. So go ahead and get out your science calendar. And our science one looks like this. We are on Thursday, May 7th. And remember, our structure is going to be the same on all of them. We have a brain pop video on the sun, and you definitely need to watch the brain pop video to help you with your ERQs. We're going to read the sun's features together, or you can open this Google Doc, or you can also just read it on your own using our pre-reading and during reading strategies. And if you'd like a challenge article, if you're interested in the sun and how it makes its energy, you can use that link on ReadWorks to read a little bit more. This one's a little tougher. And then you're going to complete your ERQs. Remember, your ERQs are where we're getting our assessment points, as well as your Edulastic. And please make sure that you're taking a picture and sending those to me through Dojo, email, or doing a Google document. So we're going to flip to our article for the day. And before we get going, there aren't many text features in this one. We can actually look at them real quick, and then I'll show you some pictures. So our essential question is, what affects the size and brightness of stars that appear to us on Earth? We talked a little bit about this yesterday. What is the composition of a star? What is it made of? And what are some of the features or things found on a star? All right, so we do have a title. We do have a diagram. It's kind of hard to see, but we're going to look at some better images, and we do have a caption. After many weeks of a blank sun with no sunspots, a small new sunspot emerged on September 23rd, 2008, marking a new solar cycle. So sun is going to have a cycle just like moon. All right, to flip it over, there's really no other text features, and this is a very short article. All right, before we go, we're going to look at some really good images, because when we look at visuals, it helps us learn. So I just Googled, and NASA has great images, but I just did a quick Google. So these are sunspots. And we're going to learn a little bit about what those sunspots are and how they appear. And this is a really good diagram. So if you look at the size of the sun, this shows you the size of the other planets in comparison. So that's one of our standards, is understanding how the size is different in comparison to planets and other stars. All right, and then this one shows solar flares. So flares, you're going to learn, is just like kind of a mini explosion. And then there's also arcs, which are just a flare that makes the arc shape. All right, so we're going to go back to our article. And please make sure you have a highlighter and a pen ready to go. This one has a lot of really good science words, so we're going to do our pre-reading where we break words into parts. Photosphere. Photo meaning image, sphere meaning three-dimensional round shape. I'm just skimming through to see if there's anything we need to look at. Ooh, okay, Jean Ollie, okay, Jean Ollie, occasionally. Chromosphere. And this word is going to come up, it's all throughout the story, so we need to make sure we know how to read it. Prominences. I think most of these you're pretty good with. All right, I think we're good to go. And before we start, we always think about our genre and why the author is writing this passage. So by now, with these science ones are almost all the same genre. So what genre is it? You should have immediately said nonfiction. And we know it's either informational or another word is expository. All right, the sun's features: sunspots, solar prominences, and solar flares. Of course, they are graced with interesting features, and we'll take a look at them here. Dark, cool areas called appear on the photosphere. Sunspots always appear in pairs or in intense magnetic fields. They break through the surface. Field lines leave through one sunspot and re-enter through the other one. The field is caused by of gases in the sun's interior. Sunspot activity occurs as part of an 11-year cycle called the solar cycle, where there are periods of maximum and activity. All right, so first off, where do these sunspots happen? In the photosphere. So the sun has areas just like our planet with the atmosphere and the core. And what is creating these sunspots? Magnetic fields. And then there's a cycle. And how long is this cycle? 11 years. It is not known what causes the 11-year cycle, but two have been uneven rotation of the sun distorts and twists magnetic lines in the twisted field lines break through the forming sunspot pairs. Eventually, the field lines break apart and the sunspot activity decreases. The cycle starts again. So what do they think causes this cycle? Magnetic fields. Huge tubes of gas circle the suns at high and begin to move towards the equator. When they roll against each other, they form spots, and when they reach the equator, they break up and the sunspots decline. So the gas is moving from the top down to the equator of the sun, just like the equator on the earth. So they start up here, and that's our equator. Oops, my time's running out. And when they reach the equator, they break up. All right. Occasionally, clouds of gas from the chromosphere will rise and orient along a magnetic line from sunspot pairs. These arches of gas are called solar. Ooh, did you remember what I said this was? Prominences. All right, so we just learned about a new feature. What was the new feature? Arches of gas called prominences. Prominences can last 2 to 3 and can extend 30,000 miles or more above the suns. Upon reaching this, they can erupt for a few minutes to hours and send large amounts of material racing through and outward into space at 600 miles per second. These eruptions are called coronal mass ejections. All right, so we learned a new one. We learned what the little area around the sun is called. We learned that prominences can last 2 to 3 months. And we also learned that they erupt. So here's your sun and this little area right around the sun. Uh-oh, this pen's running out too. Man, I'm having a hard time today. It's called the corona. Third time's the charm. Sometimes in complex sunspots, abrupt, violent explosions from the sun. These are called solar. Solar flares are thought to be caused by sudden magnetic field changes in where the sun's magnetic field is They're accompanied by the release of gas, electrons, visible light, ultraviolet light, and X-rays. When this radiation and these particles reach the Earth's magnetic field, they interact with all the poles to produce the aurora borealis and australis. So I'm going to pause this here. So we had a new one. When there is a violent explosion, what is this feature called? Solar flare. And what happens? What is the effect of these solar flares? Something is released from the sun. Gas, electrons, visible light, X-rays, and radiation. And when this is released, what is the effect of what we see in the sky? Now, I'm going to go ahead and go back. Oops. So you can see what we're talking about. I think we're pretty sure we looked this up before, but let's make sure this is what we're talking about.